Good morning. Today's video presentation is all about supercapacitors. What is the difference of supercapacitors, capacitors, and the batteries, and also the applications of graphene technology. So to understand it well, we must divide it into subparts. What is the difference supercapacitors, capacitors, and the batteries? Okay, so we must first tackle what is a battery. So a battery is a device that stores chemical energy and converts into electrical energy. The chemical reactions in a battery involve the flow of electrons from one material called electrode to another through an external circuit. The flow of electrons provides an electric current that can be used to do work. To balance the flow of electrons, charged ions also flow through an electrolyte solution that is in contact with both electrodes. The different electrodes and electrolytes produce different chemical reactions that affect how the battery works, how much energy it can be stored, and its voltage. So we must move to second topic. So the difference of a capacitors of battery. So a capacitor is a device that is used to store charges in electrical circuits. A capacitor works on the principle that the capacitance of a conductor increases appreciably when an earthed conductor to brought near it. Hence, a capacitor has two plates separated by a distance having equal and opposite charges. The space between the conductors may be filled by the vacuum or with an insulating material known as dielectric. The ability of the capacitor is store charges is known as capacitance. So the third topic we must tackle is supercapacitors. What is supercapacitors? Very similar to batteries. Supercapacitors' energy storage mechanism is both separations and movement of charges. Supercapacitors are constructed from two electrodes, an electrolyte, aqueous or organic, and a separator that allows the transfer of ions, while providing insulation transfer between the electrodes. Different materials such as various carbon materials, mixed metal oxides, and conducting polymers have been used as supercapacitors, electrode materials. Carbon technology in its various forms such as carbon cloth, activated carbons, and carbon nanotubes are the most widely used electrodes. In recent years, graphene, due to its superb characteristics of chemical stability, high electrical conductivity, and large surface area, has also been considered as promising capacitors, electrode materials. As voltage is applied to supercapacitors, ions in the electrolyte solutions diffuse into the pores of the electrodes of opposite charge. Charge accumulates at the interface between the electrodes and the electrolytes, forming two charge layers, double layers especially, with an extremely small separation distance. This is the distance between the electrodes surfaces to the center of ion layer. Carbon technology used in these capacitors creates a very large surface area with separation distance of just a few angstroms. Due to their porosity, since the capacitance value is proportional to the surface area and is the reciprocal of the distance between the two layers, high capacitance values can be achieved in a very small space. So the last part we must tackle is graphene supercapacitors. Graphene is a thin layer of pure carbon tightly packed and banded together in a hexagonal honeycomb lattice. It is widely regarded as a wonder material because it is endowed with an abundance of astonishing traits. It is the thinnest compound known to man at 1 atom thick, as well as the best known conductors. It also has amazing strength and light absorption traits and is even considered ecologically friendly and sustainable as carbon is widespread in nature and part of the human body. So graphene is often suggested as a replacement for activated carbon in supercapacitors, in part due to its high relative surface area, which is even more substantial than that of activated carbon. The surface area is one of the limitations of capacitance, and a higher surface area means a better electrostatic charge storage. In addition, graphene-based supercapacitors will utilize its lightweight nature, elastic properties, and mechanical strength A graphene supercapacitor is said to store almost as much energy as a lithium-ion battery, charge and discharge in seconds, and maintain all this over tens of thousands of charging cycles. One of the ways to achieve this is by using a highly porous form of graphene with a large internal surface area made by packing graphene powder into a coin-shaped cell and then dry and press it. Hope you understand it well, and thank you for your cooperation and God bless.